there is this valve. The supply line is connecting it to the desired value. Now the operator, what he does basically is screws or unscrews that valve, which actually changes the position of the dial. A red dial is there on the controller, remember? Now that can mean, if there is a temperature scale, it will go to a certain temperature. If it is a level gauge, then it will show some certain height of the level. Or it can be pressure, then it will be graduated in pressure, correct? Right. So since we are talking about temperature, and that controller will have a scale of temperature there. For jacket cooling water system, possibly it will be 0 to 100 degrees C. For steam or other high temperatures, it can be higher. Like for example, exhaust gas temperature, it can be graduated to 500 plus 600 degrees C. Right? Okay? So it is depending on the system and what we actually want to achieve there. Okay? So supposing then we want the jacket cooling water temperature to be maintained at 80 degrees C, which is quite normal for our plants. And accordingly, we will supply some air in this bellow so that that red dial will be positioned at 80 degrees C. This is our desired value. Okay? Understand? So what is the desired value definition wise? It is the parameter value the operator wants to achieve. Right? And quite similar to that is another term used which is called set value. And the definition is same for desired value and the set value. There is a small difference. Desired value can be like, not a concrete constant number. It can be like say 80 or it can be between 75.5 to 80.5. Doesn't make much of a difference, does it? That is our desired value. Yes? But once the dial is set at some certain point, that is the set value. Understand? It cannot be 75.5 or 80.5. It will be either 77.5 or 80.5 or 80. Wherever you have put the dial, that is it. That is a constant number. There is no variation on that number. So that is the basic difference between desired value and set value. And for some precision controls, desired value and set value is exactly the same. Where you cannot go a little here and there also. You understand? Like for example, you want to go to the moon, you want to go to the moon, not beside the moon a little bit. Yes? Right? So that is the constant, which is the set value, also is the desired value. So hardly any difference between set value and desired value. Definition wise, both are same. The parameter value the operator wants to achieve. Okay? Right. Some of you may ask me a question. You are adjusting this valve, air in this DV, and are talking about a red dial. How is that? That's a mechanical signal. Right? Okay? So I can show how that is possible. কিছুই দেখা যাচ্ছে না। I'm not very sure. But I will. So this is the kind of a fulcrum, and you increase the pressure here in this below by operating this valve. So what happens? This expands to say this point. So this end goes here, and it takes a new temperature range. So pressure বাড়াইলে কমালে এটা একটা dial-এর মধ্যে reflect করবে, isn't it? Exactly, that is what is happening here. Yes, red dial is attached with that below, with a fulcrum in between. So pressure increase means temperature is showing an increase there in the scale. So that's it. You are not moving that dial by screwing and unscrewing that. You are actually operating the valve to increase and decrease the air pressure inside the below, which is reflected by this red dial motion. Is it easy? Huh? Understand that?
Yes.
Okay. Now we assume যে আমরা ওখানে 80 ডিগ্রির জন্য ডায়ালটাকে ফিক্স করে দিয়েছি. There is some certain pressure, say 1.6 bar, something like that. And at the point when the temperature of the jacket cooling water system was 80 degrees C also, so say around 1.6 bar pressure is also available here. Okay? And our flapper is right in the vertical position. Now, this one is once and for all, you have fixed it. Can you say this is also fixed? No, if you change the RPM to a higher one, more load, higher temperature. You reduce the RPM, less load, lower the temperature, and thereby lower the pressure and higher the pressure in this below. So, যদি এমন হয় যে this pressure increases and that pressure remains the same, so can this be in the same position, because this is a link between these two belows. So এই দিক থেকে ঠেলাটা বেশি পাবে, and there will be a motion this way, correct? Bottom of the flapper will move to the right for a say certain rise in temperature. And you can also understand যদি temperature 81 হয় সে যতটুকু যাবে 82 এর জন্য এখানকার প্রেসার আরেকটু বাড়বে, সো এটা আরো ডানে যাবে, 83 এর জন্য আরো ডানে যাবে, 84 এর জন্য আরো যাবে. So it is a proportional signal, proportional motion of the link towards right. For a receding temperature, it will move to the left, and similarly in proportion. So no problem with that, right? Now, imagine nothing is happening in the rest of the places. অর্থাৎ এ যেখানে আছে সেখানেই আছে. Now this movement to the right, what happens? The distance between the nozzle and flapper is reduced. That means the air that was coming out earlier now cannot come out completely. So that will mean this pressure will show an increase. Agreed? So এই জিনিসটা যেটা আমরা পেলাম, this is the difference between these two, which is causing it. When there is no difference, this is in vertical. Okay? Right? So these two, MV and DV, whenever there is a difference, then only the flapper's bottom moves either to the right or to the left. Okay? And এই মুভমেন্টটাকে আমরা বলি deviation. Alright? So what is deviation? The difference between desired value and desired value. Okay? And deviation causes the flapper's bottom to move right or left. Agreed? So, there is this thing about the controller. Whenever there is a deviation, there is a change in the corrective action pressure. And ultimate result কি? Ultimate result হলো remove the deviation. Understand? So, desired value and desired value again will be the same. কিন্তু ম্যান ইজ মর্টাল, মানুষ মাত্রই ভুল হয় নাকি? সো কন্ট্রোলারেরও ভুল হতে পারে। সো যখন কন্ট্রোলারের ভুল হয় কোনো কারণে, সেটা আমরা এক্সপ্লেইন করব না, এবং এই ডেভিয়েশনটা হইল অথচ কন্ট্রোলার সেটাকে কারেক্ট করতে পারলো না, অর্থাৎ ডেভিয়েশনটাকে রিমুভ করলো না, তখন সেই ডেভিয়েশনের কি অবস্থা হবে? সে স্থায়ীভাবে ওখানে থেকে যাবে। That is sustained deviation, aptly said, and that is called offset. Okay, offset. Another term used is error. Error is also the difference between the measured value and desired value. So there are three terms for deviation. Deviation itself is a term, then is error, then is offset. Offset is a classic problem with simple proportional control systems. Okay, and to remove it, to correct it, an integral action is required, which we will be learning later.
So error and deviation is the same, isn't it?
It's the same, yes.
And offset is the sustained deviation.
Offset is also the same.
Offset is sustained deviation.
Same, but it is not, there is only differences. It is also the difference between measured value and desired value. You have to say that. Yes? And what is about deviation? That is corrected. What about is offset? It's not able to get corrected. Right? That is the difference. One is usually corrected, the other one is corrected when integral action is there. Otherwise, it remains there. And then we call it an offset. Okay?
Integral action not is that offset.
Integral action না থাকলে ডেভিয়েশনটা কারেক্ট হবে না। যে ডেভিয়েশনটার কথা আমরা বলছি পার্মানেন্ট ডেভিয়েশন, সেটা কারেক্ট হবে না। So that is sustained. So that is why we call it offset. Okay? All right. So I can see some confusion is there. May we share it? No? It's all right? Good. Yeah.
মেজার যখন প্রেসার দিবেন রাইটে, তখন স্যার সেট ভ্যালু যেটা অটো প্রেসারাইজ হবে না।
Are you worried? Are you worried?
No sir, not worried. I just want to explain.
Okay. The thing is that it may increase, does not matter, still it will move to the right. That is one thing. The second thing is, this valve is not only supplying, it's also part draining. Understand? So when it is pushed, still it will maintain that pressure. The excessive pressure that is created by the push will be drained out. Okay? So now we have got a temperature of something like 82, a higher pressure like say 1.7, and this is pushed to the right and the air cannot come out. So earlier there was some pressure here, right? That must increase. So supposing corrective action was x bar, so this will be added to 0.1, say, মানে এটা আরেকটু higher pressure এর দিকে যাবে। So what this higher pressure does, in this case we will use another component here. So this is the main engine cooler, okay? And we know jacket cooling water comes out and either it gets inside the cooler or it bypasses the cooler, right? So this is the scenario. So at a given point of time, যখন আমাদের ইঞ্জিনটা চলতেছিল, supposing এখান দিয়ে 40% পানি কুলারের ভিতরে যাচ্ছিল and 60% water was bypassing it, correct? Okay? and there was this three-way valve. Okay, understand? Now what happens is this corrective action signal is going right on top of this diaphragm operated valve. Okay, now there is a certain increase in this pressure, right? Because air cannot bleed out, so the pressure here is increased, so that diaphragm top এ প্রেসারটা বেড়ে যাবে, and say result হলো এই যে 45% now water enters the cooler and 55% of the water now bypasses. So আগের যে cooling effect কি বাড়বে না কমবে? Obviously বাড়বে, and that's why the temperature 82 থেকে 82 তে আর থাকতে পারবে না, কারণ আগের চেয়ে বেশি cooling হচ্ছে. So it will come down to 80. Job done. Right? A similar way of thinking will be, say this is 78, this pressure reduces, this goes out to the left, the gap between the flapper and nozzle increases, the air bleeding out is increased, the pressure here drops a little, the lesser pressure opens the bypass more, 65% water now bypasses, and 35% water goes to the cooler. Temperature will start to rise because the temperature, the cooling effect is not as it was before. 79, 80, done. Okay? Okay? Right. এখন আমরা proportional ফাংশনটা বুঝতে পারলাম যে 82 এর জন্য যতটুকু বাড়বে, যদি এটা 85 হতো তাহলে আরো বাড়তো, তাহলে আরো বেশি পানি কুলারের ভিতরে দিত, তাহলে আরো দ্রুত ঠান্ডা হইতো, রাইট? টেম্পারেচার 78 হইলে যে পরিমাণ বামে আসবে প্রেসার সেই পরিমাণ কমবে, কিন্তু যদি 78 না 75 হয়ে যায় আরো বেশি বামে আসবে, আরো বেশি প্রেসার কমে যাবে. So this will bypass even more water, so that will be, heating up the water faster. Yes? So that is proportional. It depends on the temperature differentials from the desired value. The higher it is, the more, the difference, it can be negative and it can be positive. The higher the difference, the more is the effect on the three-way valve. Yes? Right? So it will work out quite, with time, very easy. Okay? Now, this is the most simple part of proportional control. Now we have to go a little bit deeper, a little bit tougher, if you like. একটু কষ্ট হবে এখন হয়তো, এই পর্যন্ত বুঝতে কোনো অসুবিধা নেই. So next বুঝতে হইলে আমাদের বলতে হবে যে this motion of the flapper to the nozzle is so limited. তোমরা জানো যে if the opening of the nozzle is 0.7 and multiplied by 4, that is 2.8 is the maximum motion of the valve flapper. কারণ তোমরা জানো 4D ওপেনিং হইলে ফুল থ্রটল ওপেন হয়ে যায়, রাইট? একটা ভালভের ডায়া যদি হয় 40 মিলিমিটার, 40 into 4, 160 millimeter valve lift is maximum required. এরপরে তুমি যদি valve lift 200, 500 millimeter করো, it's useless. কারণ 160 millimeter পর্যন্ত উঠে গেলে valve পুরোপুরি খুলে যায়। এরপরে 161 millimeter খুললো না 200 millimeter খুললো, does not matter. Is it 4 times D or 1/4 of D? It's 1/4 of D. So 41 and 10 millimeter. You will find it in the boiler chapter. 1/4, correct. 4 D by 4, that is the maximum lift required. So if it is 0.7 millimeter, the valve dia, that is the nozzle dia, divided by 4, only 0.2, even less than 0.2 millimeter. Flapper is moving only maximum to minimum is 0.2 of a millimeter. তুমি যদি এখন ম্যাগনিফাইং গ্লাস দাও, মাইক্রোস্কোপ দাও, তাহলে হয়তো তুমি এই মুভমেন্টটা দেখতে পাবে। তার চেয়ে বেশি না। So small a motion that causes full deflection valve operation. Okay? So this means a little bit problem. কারণ সে এটা 81 হইল 1 ডিগ্রি বাড়ছে, তার জন্য সে কিছুটা ডাইলে যাবে, তার জন্য সে কিছুটা এটার কাছাকাছি যাবে, and if we say this is such a small motion, so we understand যে ফ্ল্যাপার ওইটুকুর জন্যই হয়তো দেখা যাবে যে ভালভটা ফ্ল্যাপ নজলটাকে পুরোপুরি ক্লোজ করে দিয়েছে, কারণ it moves only a little. You agree? Fraction of a millimeter we are talking about here. Yes? তো তখন কি হয় আমরা সেটা এবার জাস্ট করি। সে আমাদের টেম্পারেচার দরকার হলো 80 ডিগ্রি সি, রাইট? and the temperature is আরেকটু বাড়াই বললাম নাও 85 সে 85 degree C, and the valve is giving full deflection. Yes? Closed. Nozzle is closed. So what happens? If nozzle is closed, the pressure here is 2.0, the pressure here is 2.0, all the water passes through the cooler. Nothing is through the bypass. The cooling effect is at its maximum, highest level. The temperature correction will be very, very fast, which is all very good. Now there is a problem. If I run, sorry, I cannot run. We rather use Usain Bolt for a run, right? ও যখন 100 মিটার রান করে ওই লাইনে ফিতার ওখানে যায় কি থেমে যায়? কোথায় যায় সে? আরো 100 মিটার সে মোমেন্টামে চলে যায়, আরো 100 মিটার। But if I go slow, and this is the fita, I can stop right there. See that? So when temperature rise is so fast, or lowering of the temperature is so fast, then it doesn't stop at 80, it goes down. It goes down to 77, 78, something like that. And then suddenly the controller says, oh shit, the deviation is on the other side. So again একটা corrective action আসবে, which is in proportion, you know already. So that is also fast. So it will go like this, like this, like this, until it will settle down. Understand? That is the problem with fast operation of the controller. Now, with that, I cannot see anything. How can you guys see? Yeah? That is how the temperature is going to go up, down, a few times before it becomes 80 degrees, straight up. That is going to happen to you. And now with that, you can imagine this and this, they are going to be, expanded, compressed a few times. Now you imagine একটা তার নিয়ে যদি বারবার এরকম করো কি হয়? গরম হয়ে ছিঁড়ে যায়, তাই না? Same thing is going to happen to your bellow. এটা তারের মতোই জিনিস, আর কিছু না। And there will be একটা ফুটোশ, bellow ফেটে যাবে। This is the ultimate result. Your controller only works for 1 week and then it is finished. Understand that? So this is not a very stable operation here we are talking about. This is dangerous for the controller. And now we need to also talk about this phenomena. এই যে কন্ট্রোলারের কারেক্টিভ অ্যাকশনের জন্য টেম্পারেচার নামলো এবং ডিজায়ার্ড ভ্যালুতে যে স্টপ না হয়ে আরো বেশি দূরে চলে গেল, ইয়েস, এটাকে বলা হয় Rightly say overshoot. So overshoot is what? Is the controller is too sensitive, too fast. Okay? Corrective action is too high. Right? এরকম অবস্থায় when deviation is corrected and the parameter is creating another deviation in the opposite direction, this is called overshoot. Okay? Controller's corrective action is so fast that it doesn't stop on the desired value and creates a deviation in the opposite side. This is called overshoot. And when that happens repeatedly, this is called hunting. Repeated overshoot is called hunting. Okay? Right. So, this is the problem with our controller. Now, what we have to do is, we don't want this to happen. And for that, we have used this proportional action below. And now, how that works, you can check. Now, supposing there is a deviation, and due to deviation, the valve goes there. Yes? This pressure increases. What it does is, because of the proportional action below working here, that high pressure also goes and works on the black below directly, which is our proportional action below. Now, with the deviation, pressure increases. That high pressure also causes the flapper stop to move in the opposite direction of the deviation. Yes? Now, you must understand this. This is a proportional push. It is not equal as the earlier one. যদি equal হইতো, so এখানে এটুকু মুভ করেছে, এখানেও যদি অতটুকু মুভ করতো, the resultant would have been like this. The distance between the flapper and nozzle would not have been same. So this cannot happen like that. It cannot be equal movement of the flapper's top due to the proportional action below. It may be in proportion. So supposing এটা যদি 4 মিলিমিটার হয়, আমরা ধরে নেই যে এখানে সে 2 মিলিমিটার মুভ করবে। Okay? So still it is closer to the nozzle. Agreed? But not so high amount closer to the nozzle. Agreed? So earlier যে প্রেসারের টেম্পারেচার চেঞ্জের জন্য আমাদের প্রেসার হয়ে গিয়েছিল 2.0, now it cannot be 2.0. It is so far away from there, right? Possibly this time the pressure will be 1.8 millimeter. Agreed? Controller output will be, instead of 2 bar, maybe because of this proportional action, now will be 1.8. So which will mean, say maybe 70% water will pass through the cooler and 30% will pass through the bypass, and the cooling will not be so fast anymore. তাই না? এটা কিন্তু স্লো হয়ে যাবে, which is basically not a very good thing to happen. Yes, it's not very good. Controller যদি স্লো হয়, it's not a good idea. Don't you agree? But under these circumstances, this is good. কারণ এই অবস্থায় there will be no overshooting. কারণ আমি হেঁটে হেঁটে যে 100 মিটার যে থেমে যেতে পারবো, দৌড়ায় আমি সেখানে থামাতে পারতাম না। Makes sense to you?
Yes.
So that is the function of the proportional action. It helps to overcome overshooting. Yes, and hunting. Agreed?
For integral,
ইন্টিগ্রালের কথা তো বাবা আমি কিছু বলিনি। হুম?
for proportional action, it reduce the offset. Proportional action.
I never said that. I only have said that by adding this proportional action there, I have made the controller slow. But এটা একটা খারাপ জিনিস হলেও এটা একটা ভালো দিকও আছে। I can now avoid overshoot. Yes, which is supposed to be quite healthy for my control system. Hmm? Okay? Sure. So, যদি তাই হয়, আরেকটা জিনিস লক্ষ্য করছো? Hope you guys are able to see it. Huh? আরেকটা ব্যাপার হইলো এই আগে আমি দেখিলাম যে 85 ডিগ্রি হইলেই ফ্ল্যাপার এবং নজলের মধ্যে আর কোনো ডিসটেন্স থাকে না, ইকুয়াল কভারিং। কিন্তু এখন কি তা হবে 85 এ? হবে কি? মিন্স আগে 85 হইলে সে ভিতরে গেল, এমন ব্যাকা হইলো যে এইটাকে পুরোপুরি বন্ধ করে দিচ্ছিল, রাইট? নজলকে পুরোপুরি বন্ধ করে দিচ্ছিল। এখন কি 85 ডিগ্রি যখন টেম্পারেচার হবে তখন কি নজল পুরোপুরি বন্ধ হবে? প্রপোর্শনাল অ্যাকশনের কারণে সে পুরোপুরি বন্ধ হবে না। তার মানে আরো বড় ডেভিয়েশন হইলে সম্ভব বন্ধ হওয়া, কারেক্ট? রাইট। সো আমরা এখানে আরো কিছু তথ্যাবলী চিন্তা করতে পারি। এক, প্রপোর্শনাল অ্যাকশনের জন্য যে ডেফিনিশনটা রিটসের জেনারেল বইয়ে দেওয়া আছে সেটা হলো কারেক্টিভ অ্যাকশন ইজ প্রপোর্শনাল টু ডেভিয়েশন, which I have already explained. Remember? যখন